We have a solution called DataStream where we output these logs in real time. That match ends up in a tie, and there's going to be a super over after that. What amount of data is the right data for you to get the actionable insight? Hello, everyone. Welcome to this podcast series. In this episode, we will be talking about measurement and monitoring of quality of experience. But before that, I'd like to do a quick introduction. We have Jitendra Agarwal, the head of engineering from Viacom 18. Jit, it's nice to have you on this podcast.
Oh, thanks for having me, Hadi.
Let's talk about overall observability of different platforms. To begin with, let's talk about the server-side metrics and the client-side metrics. So at a very high level, the categorization of these two metrics are unique its own way. But would you like to share some more insights around this, Jeet, and the area where it actually impacts and provides us the value?
Yeah. So I would do further classification and say there are server-side observability. There is client analytics and client behavior observability, and there is a video matrix, video quality matrix. You need to keep these three separate because the frequency at which you will measure any video quality will be different from how frequently you will measure where people are clicking, and you will map journeys and try and find both business issues and technical issues. Right? Now, within server, of course, there are so many different components that you need to map. Your database layers, your active services, your load balancers, all the CDNs that you're working with. And a good observability solution would also map this journey back and say there is a problem that you are facing. Who all in the chain are able to see this issue?
So, observability, right? Like we are discussing server side and this thing. And then we should also talk about a little bit of data collection and how much we like,
right?
How much you
basically
collect.
If I have to put it, like what amount of data is the right data for you to get the actionable insight?
Yeah, because at our scale of operations, collecting 100% data, yes, sure, we can do. Technology supports it. Probably costs us a lot of money. But the question comes is whether it's going to give you value for money or not, right? Like whether one thing we always keep discussing is that actionable insights. Like you can collect hundreds of metrics and dimensions and this thing, but they're not actionable. There's no value to it, right? And most of the time we have found that actionable insights can come even from a small sample set at our scale of operations, be it on server side or this thing, which brings into sampling, and sampling has its own complexity because how do you do sampling? Do you collect pieces and samples which is random versus having a full view of a single user and ensuring that view of that user, like as well we were discussing earlier in the CMCD, where you could, I think CMCD, the tracing mechanism, right, where you could go back and trace entire thing. If I have partial data from the client side and a partial data from server side and I'm not able to stitch together, then it's not of value. So I think observability comes with a lot of its own complexity like this, that yes, you have so much dimensions of information, but what do you collect and how do you collect becomes interesting and aspect of it.
And Ashok, I also have one other point to make here, right? When you're saying sampling of the data for observability, can you also expand on the specific aspect about the difference between the random sampling based on a session-based sampling? Like, where does fit?
So
what use case?
I'll break it down into three kinds of sampling. One is random sampling. The second is user sampling. And third is your session sampling, right? When you're doing random sampling, that means you'll get partial views of the data which you're collecting. So if let's say I'm collecting events when the user opens the app and all of that, you'll get certain bits of opened apps, certain bits of clicked items or video starts or video this thing, right? And doing session sampling, that means when the user opened or started a video playback session, whether at the beginning of the session, we'll choose whether the data is sampled entirely or not, right? User sampling is, I would decide in my system when a user is created, whether this user is sampled or not. And that can be a variety of factors, like if it's a paid SWOT or a premium user, I might choose to sample it 100% of the time. That means for the lifetime, the user comes to my platform will always be sampled and we will be collecting data, right? So these are the three different sampling strategies.
Adi, what you say is exactly correct. The mechanics, though, is how do you collect the data from so many users? When you're saying you're collecting from a few percent, but it's of 30 million people, you're still getting 1 million records per second coming in. Log lines. At Akamai, we're outputting 70 million log lines per second across lots of customers. And we have a solution called DataStream where we output these logs in real time. But they have to go somewhere, right? Something has to receive the logs and be capable of processing them at gigabits per second rates for continued periods of time. And that's a challenge. So, what we've developed at Akamai is a solution called Traffic Peak, which is basically a home for the logs, a very useful one that can collect logs at very high scale, that can allow you to then analyze the data, present visual interfaces, graphs, and trend line behaviors of this data. And what it does, it's built in conjunction with Hydraulics, who have a technology for compressing the data. So uniquely, we can store data from 1 minute ago, but also from 15 months ago. 15 months is the default collection period, and have sub-second access across that entire data. So that's very useful when you're trying to make decisions. Okay, what happened in the last 6 events? I can instantly analyze them, as well as what's happening right now in this event. And we used it in the Super Bowl, which is the US version of IPO finals. And it was processing 53 billion records with multi-second accuracy, which I think is quite fantastic from an observability point of view. And I went down this road because your original question is, it's easy to say we want to sample and analyze, but how do we collect it? How do we collect concurrent information and process it? And just storing it, analyzing it is in fact an engineering challenge.
I think for the longest time, we have been thinking about processing CDN logs, right? Like we have always discussed, it's like it's a non-starter. Like for until the beginning of this year, it was like a non-starter. We'll not even talk about CDN logs or processing it. The volumes are so high across APIs, media, and everything. Just becomes like it's a non-starter conversation. But I think the technology has matured. But still, there is cost. Two aspects which you should talk about is one, how real-time is real-time. How much real-time is important for metrics. The second aspect we should talk about is log versus metrics.
Yeah, I want to take a quick peek on the metrics or observability side. All of the same metrics, all of the same observability is also used for any product ABs or any technical ABs that are done. So the sample or sampling rate has to take care of any error rates that sampling introduces. It's all good to have sampling at streaming scale. Even 1% sampling will tell me if a particular node in a particular ISP is suffering and should be taken out. Or there is a problem with the origin and everybody has a problem. All of this is easy. But when it comes to client-side metrics or when it comes to server-side metrics, the sampling cannot be so small that you are unable to say, hey, this AB, which one won really, because the sampling itself has introduced some error, right? Then I'll come to the topic that Ashu has.
No, real time.
Real time. For video streaming, if it is not real time, you miss the boat. The Traffic Peak solution is helpful because it can actually tell me even before my clients observe an issue and report the issue. Clients is all Android, iOS, TV clients. They have a bit of buffer. So when the error happens on the backend or on the streaming side, and when the players see there is a gap, Hydraulics is able to see this beforehand, and I can say, hey, this is an error that I expect, and I can map it and say, yes, this error happened. I know the root cause already, even before the clients observe this. Right. For a live stream, it is important. I have a 4-hour match. If I spend 10 minutes just finding out there was an issue 10 minutes ago, I've already lost that match. For things like how many customers came to the platform today, that's a business metric. I don't need to have this in real time, even though we do this with our
We show that view counter.
the concurrency counter that we show. It's not. It's a metric that can actually slow down. And when people are talking about scaling, and Will talked about millions of log lines, one of the things that you can do is sampling, of course. Another thing that can be done is to decide what events you need to process in real time and be able to query real time. What events can be processed at a slower rate and can be processed after the match finishes.
Yeah, because there's a cost of processing it in real time, right?
Yeah,
Like
there is a cost.
no matter what technology you deploy, there is a cost associated. If you try to process all that 70 million log lines which Akamai is emitting, if I try to process all of that in real time, there's a huge cost, right? Even with the best compression, it is still sizable volumes.
So real time is real time sometimes, but for a lot of events, you need to take a call and say, hey, this can be processed later. In fact, I would go and say, maybe process everything real time until you hit a limit and say, after 50 million people are on the platform, we know that we need to degrade some of these events, and we plan it like before any of these big tournaments. We do all of this load test and say, this particular event at this particular RPS or this particular concurrency, we will degrade it. It will be reported 15 minutes later.
Right.
There are no real-time alerts based on this. Analytics is same, so you need to be aware what is observability and what is a product or business metric from the same analytics that we report.
I think performance-based decisions is where you want to save your resources and your processing for real time. They got to be performance related. The A/B testing, the business decisions, how many people watch this event, that can all be deferred. And the more you can defer it, the better your economics of collection. And I want to go back to a point Ashu mentioned about the difference between logs and metrics, right? Logs is your raw material, and log line is huge. You don't care about most of the information in the log line.
Yeah.
You want to distill it down to how many users do I have and do they have a problem? That's two things, but you've got 500 characters every 2 seconds coming in. So you do want to filter and process your logs as far upstream, as close to the source as possible, and start moving the metrics around, right? Because metrics you can aggregate far more efficiently. You don't want to be lifting heavyweight log files throughout your distribution chain. And there's a big, and people say, well, why doesn't Akamai generate the metrics up front? For the cost reason. The cost we would ask people to pay for that is high because the processing cost to process all those logs is also high. And so it's a challenge between when we're going to spend the resources when we absolutely need the lowest latency, and that's almost universally going to be for real-time performance.
The other important bit about log and observability is how much of the engineering cost, both from people, resourcing, infrastructure, should be on observability, right? Like there's no end to observability, right? I can collect as much APIs and as much data as I want, instrument as much, spend half of my engineering team on just observing and collecting data and collecting it, bringing it back to a central location, processing it. How do you select?
I know how you select, and Nick told me this in one of the discussions. He said there is some observability that's your headlights if you're driving a car, and there is some observability that's steering. You may be still able to drive a car without your headlights, you drive in the day, but you do need a steering if you want to decide where you want to go. So maybe take that and say, so for example, you are making your real-time decisions on which network and which state should have which CDN percentage from your multi-CDN discussion. If you do not get this QoS real time, then you're making those decisions too late. So that's your steering.
Yeah.
You can't not have it near real time and spend money, spend your team's bandwidth, spend all the databases and caches that you can spend on it.
All right. Thanks, Jeet, Ashu, and Will. Let's move on to the next topic. This is broadly on to the aspect about for any live event. Like one of the major aspect to be successful is about people behind the scenes. So we have a bunch of teams who help us to deliver these events. For example, we have the implementation teams who gives us the different varieties of features. We have the support teams who works around the clock to fix something. Ashu and Jeet, there's more to you, right? We have seen multiple events happening, right? And there are many instances where there are multiple things which have went as expected. And there are a few things which did not go as expected, right? Now, my specific question is about when there is a eventuality on the platform, right? How do you align different people or different vendors and the people to your in-house people and collaborate?
We run a live war room for all big events. There is a single call. All of our partners, important partners, are on that call if there is a big live match going on. There is all sorts of observability, all sorts of alerts available, but I cannot be spending 10 minutes getting an important partner on the call when I'm doing an IPL day one or finals of, Olympics or whatnot, right? So that's the first thing. Even though after COVID, we are all spread out, this used to be in person at one point. The war rooms used to actually be rooms. Now it's a call with multiple rooms where each person is attacking each small or big problem. We also do what is called a game marshal protocol, where somebody is responsible for orchestrating this event. Everyone, all partners who complete their checklists report to the game marshal and says, hey, we are done with this. Game marshal can also take help from other people, redirect people from one room to another and say, there is a big or seemingly big issue here. Can you go and look at this? That's the real time. But even before this, a lot of preparation happens that says, these are all the CDN partners we want to work with. These are all the capacities we have access to. This the distribution that we are looking at. These are the bitrate ladders that you prepare. These are the services that are new. Let's load test them, establish their limits. These are the databases that are new. There are schemas that are new. And all of these also get playbooks to say, hey, when this goes wrong, what do we do? Let me take a hypothetical example. Let's say, or maybe a real example, the stump cam goes away. Like somebody does a very good ball or a stumping and stump cam can go away.
Just further context for our viewers, I think stump cam is one of the additional stream which Viacom does it for Tata IPL. Yes. It has a different angle of the whole view.
There's a camera on the middle stump which is there, and if sometimes the ball hits it, camera or the wiring to the stump can get damaged and it doesn't recover.
So the team already builds an SOP and says when stump cam is down, and it does go down at least once in a good match, there should be a technical slate that says, this will be available after XYZ time. In case the stump cam does not recover, that has happened sometimes, or in some cases, another cam can get damaged. The bird eye cam can get damaged. People should not be making those decisions in real time. Most of this stuff is expected. You decide that SOP for this is put a technical slate. If it is not recovering, remove it from discovery. Because end of the day, customers should not see a non-working video stream. If the video stream is not available, they can still say, hey, what happened to stump cam today? And that can be communicated with them with tickers and whatnot. What happens when there is rain? What do you do? There is no video stream. They're real life scenarios, right? For most of this stuff, we prepare the team that is doing production, the team that is doing play out or ad operations, team that is doing streaming. They're well prepared with all of this stuff.
Yeah, I do want to understand how, this is from a publisher or from our platform point of view, right? But how does internally you guys do the planning? Do you want to shed some light on that?
Will, do you want to take that?
Maybe you want to talk about what we do for IPL specifically. I can talk generally about the relationship between monitoring and people, right? Humans in front of screens. Because most monitoring jobs are looking for anomalies. If you think, what are most people in that war room doing? They're looking at a chart or a camera feed from, say, the stump camera. And if it goes down, they look up in a document and they call someone or they press another button. Those tasks can be automated. We have Gen AI. It's not perfect, but it's a lot better than people are at looking at data. So I think jobs that are boring, mundane, and repeatable, even in a war room situation, should be automated. What humans are still necessary for is dealing with the unexpected. An AI system can only find what it's been trained to find. So take the stump cam example, right? It can tell that the stump's fallen down. But what if it's put in back to front and it's staring at the wicketkeeper instead of the batsman, right? The AI says, oh, that's fine. I see a picture. It's all good. But a human knows, hey, that's a problem. That's still wrong. I know it's wrong. So we'd have to go back and train the AI to recognize wikis versus batsmen. But we still want humans there to make the unexpected, to deal with the unexpected. But I think we're going to see an increasing rise, and we should see an increasing rise in automated systems for anomaly detection. So the war room evolves to a system where humans are basically doing nothing other than reacting to unexpected situations. And that humans are still pretty good at.
I want to take this example and say when the stump cam goes down, nobody touches a hand and says this is done. This is all automated. That there is a black coming from the source. That means there has to be a slate. Of course, you still need humans to make decisions. I would say, humans are making decisions more than doing what is.
The thing is that we do have automation. Like, I think the automations and systems are in place, right? You're getting all these metrics, there are alerts, there are these anomalies.
Yeah, the ones that happen often become automated.
But the important aspect is there is still variability. There are so many variables, right? For example, where are you in the gameplay? Okay. A typical training, you would have said that, okay, if my traffic is peaking beyond a certain concurrency, then do this dynamic shift of the traffic or reduce bitrate qualities, and we might have steps to ensure that the platform remains stable. But if the same thing is happening at a 19.5 ball, what do you do? Now over there, just 19.5 is not important. What if that match ends up in a tie and there's going to be a super over after that? So now how much training do you do? How much automation do you do for these scenarios become really, like in cricket, it's possible, right? That you might get a super over after that. So you have to be mindful.
We do handle super overs much better now.
So there's so much of variability, which I don't think you can automate that easily. I want to add something to this because
I think from the Akamai perspective, right, I think we also have a similar war room in place during the IPL matches. On an average, we have close to around 4 to 5 people joining to support an event. And there's a clear definition about how each individual looks at this particular event. They have a set SOPs defined. And on top of that, I think we have multiple observability within our systems. We have a direct escalation channels just in case something goes wrong. We have a set SOPs to mitigate any issues which we are able to find it. So there is a saying in Akamai for IPL, like it takes a village for us to support this event. And and the last time when I saw something in my internal group was there were close to around 170 participants actively supporting this particular event. So I feel that, the amount of effort, I think the teams which takes to provide the viewer the good viewing experience is monumental.
I also want to point out for our audience that you think that a war room is a place where, a problem happens and people gather around and discuss the solution to it. A live event, someone once told me, and I like the analogy, is like a car crash. Okay? When something goes wrong in a live event, you never plan to crash your car. And when your car's crashing and you're upside down, you don't calmly have a debate about, well, how do I get out of this? Why are the wheels at a funny angle? You desperately try to get out of that. It's chaotic. And a live event going wrong is very, very similar for those who've been inside it. it's very hard to make rational, calm decisions. So you have to practice. You have to know exactly what problems are going to occur and how I'm going to react to them. And it's all storyboarded out well ahead of the event. So when it happens and it's chaotic and you're upside down, you know exactly what you're going to do.
I wrote the guide that says how to handle a live incident here. The first thing that I wrote was don't panic. Just makes sense. There is another one that we follow and we train our engineers to do is mitigate first. And then you can debug and solve.
Figure out why it
later.
happened.
Yeah. Mitigate first. So there is a saying that Akash, our CDPO, often tells us, video must play. This is the 3 laws of video, just like 3 laws of robotics. So the video must play. Don't bleed publicly. You may be having, dead servers and whatnot, but your customers should not know. Right. That's the mitigation part. And of course, always be monetizing. But these 3, if we keep these 3 in this order, a lot of decisions in those incident scenarios become easier for the team to take.
In fact, one of the critical, it's easy to build alerting and automation and this thing. It's difficult to train people for this kind of scenario, right? Like, how do you train humans to handle car crash? Like, how do you, you cannot simulate car crash and this thing. But we do try to run these game days or drills where we simulate, we push people to treat it like there is a live issue happening, right? And react to it. With a similar thing, one often stories which is when you're doing load testing, we're running a load from a tool, right? So the tool has some stats, it's telling you where the problem is. You can figure it out which API is done on the same. Often engineers and developers would come and say that, hey, I want to know where it is failing. I'm like, when it happens in live, you will not have that load testing tool, right? Which will tell you where your system is failing. You have to figure it out on your own. You cannot expect someone to come and help you and tell you where the problem is. If that was that easy, then life would have been easier for you.
Like Will said, you have to prepare for it. So there are game days that we do where very similar load tests happen, similar streams are rerun, and Ashu goes and switches off people's databases, and then they have to figure out, they have to actually present an RC and say, this is what happened, or we were not scaled enough, or our scaling ladders were incorrect. But these are all good exercises, and when we see production issues, I can see that the team moves much faster because they have done some simulation. It's still not, I wish we could move even faster, but it's still better than what it would have been if people had not seen these fake drills.
Do you run chaos at your networks?
Oh, so that's interesting, right? It's like randomly push buttons. We don't have a system-wide effort to do that quite yet. We have enough natural monkeys in our network that we don't. We have a very complex network, and it gets to the point that the chaos approach is interesting because it says you can never QA the complexity of all your problems. When you reach a certain level of problems, you cannot predict the outcome or the interaction between them. And in all the service incidents that we have under the covers that we deal with, they were always unexpected because we have a strong QA program. And if we could predict something might happen, we can test for it and we can avoid it. So the chaos approach is forget trying to predict it. Instead, make very robust detection systems and then very efficient remediation solutions. So you detect, you remediate, and you move on. And you're not stuck in this world of trying to predict and prevent my problems. But then when they happen, they're completely new and I have no idea how to solve them.
All right. Thank you guys for your valuable insights. Moving on to the last topic. As you briefly touched upon it, Ashwinji, it's about how much automation can we achieve in this landscape, right? We have seen that machines have solved most of the issues and we have been able to automate it. I think we have seen multiple services and SOPs within Viacom getting automated. But when it comes to live streaming or the ecospace around that, I think we tend to fall back to people. Why do you think that is happening? What are the aspects of which can be addressed and what are the aspects of which cannot be addressed?
I think we covered this broadly.
I would say part of it is how much time you have gotten to solve the problem, how many times you have seen a problem to say, this should be automated. Part of it is, should it even be automated? Like, it doesn't make sense for me to automate this because it's economically viable. It's not economically viable. Yes, there are more and more problems that I thought I will almost never automate.
Right.
I'm now saying, hey, I can automate this stuff. And that's happening so fast. So I will still not say 100% automation, but I think we're going towards automation more and more and more. Nobody starts streams on their own. Nobody switches to slates on their own. Nobody, says, I have a complaint from customers and that's why I'm making a change on this particular network and this particular CDN. So a lot of stuff is automated and more stuff is getting automated, but I would still say we will create new problems. And
As you automate.
As we automate, we will also
Indeed.
have significantly more number of people coming on the platform. We'll have new form factors, devices. And that's why I go back to Will and say, you cannot test stuff 100%. Today, I release my Android apps and stuff to a beta set of customers, to see if I have introduced a new crash states. I have verified all sorts of functional test cases and automation, whatnot. But any crashes that my team could not reproduce show up in a beta or show up at 5%. They don't even show up at 1% sometimes. Right. So that observability and being able to react to that observability, that means we need switches to say, can I disable this particular feature? Can I disable this particular ladder? Can I disable this particular...
We run a full can I disable exercise.
Yeah.
Like we run an exercise where we go about our entire plan and say, can it disable every aspect of this without impacting anything else, right? Like you should be able to operate your platform in as lightweight manner as possible.
Yeah. And it's also useful because there are platforms like Android Go, which have very little memory, and then you have to necessarily go and have some features that I would give to somebody who has a very fancy phone, costly phone with lots of RAM. So I would say, same code, this feature should not run on these low memory devices.
Right.
I want to quickly talk about downside of automation. Okay. While automation is nice, one key problem I've seen, the stuff which people have automated 1 year ago or 1.5 years ago, and people have lost tribal knowledge of what was the reason it was automated and what was the reason it was checked. So when an incident happens or we deviate from that automation plan and people get into a room to figure out what really happened, it just becomes hard. Those kind of chaoses is where human tendencies to react becomes tricky. And
automation becoming magic is a real risk.
We should point out Gen AI systems are non-deterministic. They will make a decision, but it's very hard for them to tell you why they made it. And it's also very hard for you to change the decision they make. You have to retrain it. And that itself is not a precise action. So they're great when they work. They're very difficult to change when they don't, or they're making the wrong predictions. We see this with the generalized language models coming out now. They start giving the wrong answer, and it's not an easy or an instant fix. So automation gone wrong can be terribly destructive.
If you are using power windows, and everybody has power windows in their cars, I also want a manual option along with the power window. All sorts of automation can exist, but people still should know how to roll down a car window manually whenever needed. And that's why you see all sorts of window smashers and everything that people buy in their cars. My teams have window smashers. Will, what do you think about this?
Yeah, I have a similar anecdote from a US broadcaster who had a war room set up, and they were preparing and testing for a big event. They had mezzanine encoders, they had screens, and everyone was sitting down, and they're prepared to deal with internet problems. and the test started, and their senior in the VP of engineering walked around and started randomly pulling out the plugs to various devices, to mixers, encoders, and lighting even. So people had to work in the dark. And the point was they were not expecting this, but it was a great test of things going wrong and making sure that your team is robust, that they're not panicking, and that they have procedures for events that they haven't predicted, right? And I think that's a very interesting way. I'm not recommending we do it all the time, and it's quite disruptive, but I think the philosophy of how do you predict what is unpredictable and therefore recover from it is a very interesting one in terms of live event production.
With JioCinema, it's Ashu who does this to people. He also sends pager duties late in the night saying, hey, are people responding in time? But these drills are important if we want faster responses, correct responses.
All right. That's the end of this particular episode and the podcast series. Thank you so much, panelists, Ashu, Jeet, Will, for your valuable inputs.
Thank you.
Thank you, viewers, for watching us. Until next time, goodbye and thank you.